14, 13, T-minus 10, 9, 8, 7, 6, 5, 4. We've gone for main engine start. We have main engine start.
When the Space Shuttle returns to flight later this year, its first payload will be the TRW-built tracking and data relay satellite known as TDRS. This will not be the first time this NASA satellite has made history. It is the largest and most sophisticated communication spacecraft ever launched and provides comprehensive telecommunication services by relaying voice, television, digital, and analog signals. Here, shown undergoing final integration and test procedures at TRW, is the third in a series of these satellites built by TRW Space and Technology Group in Redondo Beach, California. The first satellite has been in orbital operation since the summer of 1983, and the second was lost with the ill-fated Challenger in 1986. The mission of TDRS is to provide NASA with communications and data relay between its low Earth orbiting satellites, including the shuttle, and the ground. TDRS is a huge spacecraft, weighing approximately 5,000 pounds. When it reaches its station, some 22,000 miles above the Earth, its solar arrays will be unfolded and extend over 50 feet from tip to tip. The spacecraft operates in 3 frequency bands and can handle up to 26 satellites passing beneath it. A virtual antenna farm with 7 antennas, including a 30-element phased array, TDRS is the first telecommunication satellite able to operate on 3 separate frequency bands simultaneously. The satellite's high data rate of 300 million data bits of information per second is capable of relaying the information packed in 100 volumes of an encyclopedia in just 1 second. TRW is building 6 of these spacecraft for NASA. During September of 1987, the crew of Discovery visited TRW to see firsthand the payload they will be carrying into orbit. In the 5 years that the Flight 1 spacecraft has been in operation, TDRS has been supporting all shuttle operations, as well as Landsat and other NASA spacecraft missions. It represents a significant improvement in utilizing our space resources. In the past, orbiting spacecraft could communicate with Earth only when they were in sight above one of several ground tracking stations, typically less than 1/5 of the time. When the constellation of 3 TDRS satellites is completed, spacecraft will be able to communicate with Earth through 80% or more of their orbit. As the launch date nears, TDRS-C will undergo final checkout. It will then go into a protected packing container for convoy to Los Angeles International Airport, where it's loaded on a C-5 transport to Cape Canaveral. What impact does TDRS have on the American space program? As an example, back in 1983, the crew of the 9th shuttle flight was the first to relay their data through the TDRS network. In that single 10-day mission, more information was relayed to the ground than in all 39 previous manned space flights.